Welcome to everyone. Today we are going to discuss about the floating bodies, which is of class 9th physics. So let us discuss the first concept, which is related to thrust. So what is the thrust? A thrust is the total force exerted by an object perpendicular to a surface. It is the reactional force that occurs when an object applies a force on a surface. So the meaning of that is whenever we are acting some force perpendicularly on the certain surface, then we consider it is as a thrust. Now let us consider a rectangular block of a mass 2 kg placed on the ground. The weight of the block acts downwards, creating a force on that surface. The thrust exerted by the block on the surface is given by its weight. So it you can take as a formula: thrust is equal to a mass into gravity. Here that is acceleration due to gravity. The mass of the body is 2 kg and acceleration due to gravity is 9.8 meters per second. So when you multiply this both, we get 19.6 newtons, where we call the thrust acted upon this block is 19.6 newtons. Now the units of thrust, which is called as Newton. It is also, we can say, kg meter per second square, but which is nothing but called as newtons. So the SI unit of thrust is newtons. In the same way, if you go for the CGS units is dyne. So here we have both the units, one is SI units and the other one is CGS units. Next, we can finally say the thrust is the force and is measured in the same units of force. Means, as already we know, the units of force is also newtons. Here the units of thrust is also newtons. So it acts perpendicular to the surface where the object is in contact. Means whenever the thrust is acting, means the object should have a contact between these both. Now let us consider about the second concept, which is called pressure. What is the pressure? As already we know, a pressure is the force exerted per unit area on a surface. Means here thrust is we take with a total area, but the pressure we take per unit area. And mathematically, the pressure is given by the formula P is equal to F by A, where F is called the total force exerted by the body and A is the area on which is exerted. As here we said already, where P is the pressure, F is the force applied perpendicular to the surface, and A is the area over which the force is distributed. Means how much area it is taking when we are applying a force. Now coming to the units, the SI units of the pressure is Pascal, and its short form we can say as PA, where 1 Pascal is equal to 1 Newton per meter square. Why we are taking here Newton per meter square? Means force is given in newtons and area is given in meter square. And the other units which we can use instead of pascals as a larger and smaller units, bar and atmospheric, which is called as ATM. Now coming to pressure is inversely proportional to the area. Means as the area increases, the pressure exerted by the body is decreases. The smaller the area, larger the pressure. So the pressure is a scalar quantity which has only magnitude, no direction, because it is having some value. And one more thing you should notice, due to this reason only, you see that the objects which are used for cutting, like a knife or axe, etc., will have a very small area so that the pressure exerted by that is more, and we can make with less force to cut the objects. Now let us discuss about the next concept, which is called applications of pressure. What are the applications? First one you can see here, a camel walking in a desert. So here the camels can walk in a desert easily because the feet of these camels will be very broad, means they cover larger area. Due to that, the legs, that is called feet, will not penetrate into the sand easily. That is the reason we say that camels have a broad feet which reduces the pressure on the sand, allowing them to walk easily without sinking. Because of its larger area, the pressure exerted by the camel onto the sand will be less, due to that it will not sink. Same way, one more application you can see, the heavy trucks, means the heavy vehicles like trucks which carries a large weights. They will have the wheels with broad width, or they have a multiple wheels. Why? Means when they combine the multiple wheels, the width of the wheel, that is called tire, will be larger, so that the pressure will be very less. So that's why they say that trucks are fitted with multiple wheels to increase the area of contact, which is reducing the pressure on the ground and preventing the damage to the roads. Means if you consider this is one wheel, this will be the width, but if you take one more wheel along with this, then you will have this total width as a broad area. So as this is a very broad area, the penetrating on the roads will be very less. Due to that, the roads will not get damaged, and also they can easily move. Then the third application, which already I told you, knives and blades. A sharp knives have a smaller surface area at the edges, which increases the pressure and makes cutting easily. As they are having a less area, with a less force, more pressure is acted, so that the object will get cut easily. The next one, foundation of the buildings. Means if you see, when they are laying the pillars for construction of houses or construction of multi-storied buildings, anything, at the floor they will keep a very large foundation, means they keep a large area in this way, so that the foundation is large area, the pressure acted by that pillar on each will be very less. So due to that, the building can be withstand more without penetrating into the soil. So generally if you see, the pillar size is only this much, but the foundation size is this very large. This shows that the pressure will be very less, so that the pillar will not penetrate into the ground, so that the construction will be safe. So that only says, see, the foundation of tall buildings are made wider to reduce the pressure exerted on the ground, preventing the buildings from sinking. So that if one pillar or two pillars will sink automatically, we know that the building may collapse. So that is the reason why. Next, the pressure is widely used in engineering and designing of balancing forces and prevent the damage by optimizing the area over which force is distributed. Now come, let us discuss about what is the relationship between thrust and pressure. So here you can see, thrust is the total force exerted by an object perpendicular to the surface, whereas pressure is the force exerted on unit area. And measured in newtons, pressure is the force exerted per unit area. So here you can see, this is, and this is a small variation which you can identify about the thrust and pressure. and it is measured in pascals, and this is measured in newtons. Coming to mathematical relation, P is equal to F by A, where P is the pressure, F is the force, A is the area over which it is acting. Pressure increases as the thrust increases also, means force increases indirectly, provided that the area is same. Means P and F means pressure and force are directly proportion under constant area. Same way, the pressure and area are inversely proportion. Means if the pressure at a constant force, means if the force is constant, if the pressure is increasing, area should be decreased, or area is increasing, means the pressure will automatically decrease. So that's why we say that pressure and area are inversely relation, whereas pressure and thrust or a force is directly related. Now next, coming to pressure in fluids. As know, what are fluids? What are the fluids? The fluids are liquids as well as gases. A fluid is a substance that can flow from one point to another point, means without any external force or without any external applications, the fluids will flow from one point to other. Like if you release some air, gas in the atmosphere, it goes or it occupies the total room. So that's why we say it is a fluid. So here fluids are two, as we said, liquids and gases. This both comes under fluids. And we know that the fluids exert the pressure in all directions. What is the meaning of pressure in all directions? Means it exerts the pressure downward, lateral means sidewards, upwards. So here sidewards means we can take as a left and right also, not a problem. So up, down, lateral. So all the four directions, that's why we say the fluids exerts pressure in all the directions. Now let us see downward pressure. Fluids exert the pressure on the base of a container due to their weight. Means if you take any container, when you pour some liquid in it, then it exerts a pressure. That is the reason that object will move into downward, or it will be get compressed. To know that this downward pressure, a simple example you can take. Take a one sponge. Take a one sponge or a compressible rubber and take one container, any one container which is very less weight, so that the sponge or a rubber will not get compressed. Now you pour some water in it. Due to the pressure exerted by the water on this base, the sponge will start contracting, means compressing. So this shows that the liquids or the fluids will exert downward pressure. And also you have one more activity also, we can say lateral pressure. So how can you say that the fluids exert lateral pressure? Lateral means sidewards. For that simple, you take a one container and fill it with some water. After filling it with water, just make some small hole here. Then you will see that the liquids will start flowing from this direction, where we call this one as liquids flowing laterally, means their pressure is exerted sideward. If there is no sideward, they has to move down along with the container, but we see that they are pushed to sideward something and then start moving down because of gravitational force. And finally upward pressure. So you can say that The liquids or a fluids exerts upward pressure. Simple example which all of you know. Take a one container and fill it with water. After filling with water, you take a one empty water bottle which is capped or a rubber ball. Just compress to the bottom of the water and release, then it comes up. So this is moving up due to the pressure exerted by water upward. So this shows that these all the three explanations helps us to say that what the fluids have a downward pressure, lateral pressure, upward pressure. Now let us see, a pressure in fluids increases with depth. Means if we are going deep into the fluid, means as bottom and bottom, the pressure will be more. The greater the depth, the greater the pressure exerted by the fluid. Now let us observe the mathematical expression for the pressure in the fluids. So what is the mathematical expression? As already we know, pressure in a fluid depends on the depth, density of the fluid and the gravitational acceleration. Means it depends upon three. One is depth, second one density of the fluid, and third one gravitational acceleration, means acceleration due to gravity. We are given by the formula pressure is equal to H rho G, where H is the depth which is called height and rho is the density of the fluid, whatever the fluid which are using there, in which fluid the pressure is exerting, and G is the acceleration due to gravity. So this is the mathematical formula which you can see. Pressure is equal to H into rho into G, where P is the pressure at a depth H and where H we call it as a height and rho is called the density of the fluid which already we discussed, and G is called acceleration due to gravity. So here why we are saying the depth as the height means any which is vertically related components we call it as a H, means depth indicates moving down from the surface is called as a depth. Coming to density, denser fluids exert more pressure at the same depth, means if the liquids is having more density the pressure will also be more. Why? Because rho is nothing but density. If density is more, pressure is more. So you can see if the depth is more, pressure is more, density is more, the pressure is also more. So let us see next, loss of liquid pressure. So what are the loss? As we have seen, the first law, pressure at a point inside a liquid increases with depth from the free surface. Means what is that free surface? Means if you are taking, this is a one container where it is having some water here. Now this surface is called as free surface. From here onwards is called as free surface. So this is the surface from the above level of this liquid is called as a free surface. So from here, how much depth we are taking an object. Now if one object is here, this is called as the depth. If one object is here and this is another depth. So here if you take this is object 1 and this is object 2. Now we say that the object 1 is more deeper than the object 2. So in this way we take with the depth from the free surface. Second one, we will consider Pressure at a point inside a liquid increases with the density of the liquid. Means if the density of the liquid is different, automatically the pressure will be different. Why? Because the density is directly proportional, as we say that by the equation P is equal to H into rho into G, where rho is called density. Third factor, pressure is the same in all the directions at a given point in the liquid. Means if you take a object at this point, the pressure will be same in all the directions. Means even it is acting upward or a downward, any direction, all this direction, the force will be, that is pressure will be same. And the fourth law, at the same depth, pressure is equal at all points in the horizontal plane. So what is the meaning? So the meaning is that you can observe, if you take this at this depth, this is actual level, let us assume this is one depth, means at this point the pressure will be same, at this point also the pressure will be same, at this point also the pressure will be same, means irrespective of the container distance or the base of the surface, that is the edges of the surface. So that only is telling at the same depth pressure is equal at all points in the horizontal plane. This is called a horizontal plane. And at last we can say a liquid seeks its own level when allowed to flow freely. Means the water will take its own level. So it doesn't have a different levels when it is made to free flow. So these all are called as laws of liquid pressure. Now finally, the pressure in a liquid depends upon depth, density. Why? The G value is same, that is acceleration due to gravity is same, and it acts equally in all the directions at a given point. So these things which we have to note. Then coming to the next one, transmission of the pressure in liquids. So how the pressure will be transmitted from one point to another point within the liquid. So which is explained in the terms of Pascal's law. So what, let us see. A Pascal's law states that the pressure exerted at any point in an enclosed incompressible liquid is transmitted equally in all directions. Why is mentioning the incompressible liquid? Means if it is a compressible, then the liquid starts getting compressed so that there will be no pressure acting at other point till the compressibility is completed. So that's why he's telling that incompressible liquid. So for that reason, let us take what it says. Pressure exerted at any point in an enclosed incompressible. Means if you take any liquid which is an enclosed incompressible liquids which is transmitted equally in all directions. So if you take some liquid is taking at this point, then what happens? The pressure acted will be same. And we have one small activity which you can take. If you take a round bottom flask and which is having holes at different positions, holes at different positions, and if you fill the liquid in this and if you keep a airtight piston, so when you keep a airtight piston, the liquid will not flow because there is no pressure exerting. And when you apply some force at this piston tightly, then the liquid will move from all the holes equally at a time. So this shows that the pressure is transmitted equally in all directions. So that only he said here, see, same activity we can see in the form of a point. A round water flask filled with water and sealed with an airtight piston. When the piston is pushed, water jets out equally for all the openings, showing equal transmission of the pressure. So this we can identify, which is called as pressure exerted at a point is acting in all the directions. Consider the piston at different pistons or positions in the vessel full of water. Second thing, when the pressure is applied on one piston, the pressure is transmitted equally to all other pistons. Means if you are having a multiple pistons, instead of holes, if you have a pistons here, all the pistons will move equally at a time. That force applied on the piston F1, F2, F3, etc. are proportional to the areas of their cross section. Means if I take a simple example, if I am acting, let us take these are the three containers. Here there is a one piston and here one piston, and I am keeping one more piston here and here. When I apply some force at this piston, all these three pistons will have the same force, and these pistons will be having, depending upon their area of cross sections also. So it is given by mathematical expression P1 is equal to F1 by A1, where F1 by A1 will be equal to F2 by A2, which will be equal to F3 by A3, so on. So that indicates that the pressure at specific point is related to the different points based on their areas. Now as we said, that is a Pascal's law. Let us see what are the applications of Pascal's law. What are the applications of Pascal's law? One is hydraulic motion, or we can also sometimes say that hydraulic press or hydraulic lift, which are all comes under these hydraulic missions. A Pascal's law is used to multiple forces in the machines like hydraulic press, lifts and brakes, hydraulic brakes. Why means? Because when you take a heavy objects, if you want to lift them, it is very difficult directly. So but by using this Pascal's law, by applying the force at small area, which can be multiplied number of times, so that the force will be increased, which helps to lift the objects. Let us see what is that one by one. A small force applied on a small piston can generate a large force on the large piston. Means if you take, this is a smaller piston, here if you are acting some 1 Newton of force, let us assume, then if you take, this is another piston which is having a larger area, let us assume, then this force when it reaches here, it will become multiples of it. Like it may become multiples of 10 or multiples of 100 depending upon the area. So this will help us to make the heavy objects to lift with a small force. So that only see, a small force applied on a small piston can generate a large force on a large piston. So let us see here, he is telling the construction how it works. Two cylindrical vessels, a small cross section and the other one is a large cross section, are connected and filled with a liquid. Like means in this way if you take, so if you are connecting with this liquid, this is larger piston and this is smaller. When a force applied on the smaller piston called X, this is X, which is transmitted to the larger piston in the vessel Y. So this is Y. Mathematically you can observe that F2 by A2 is equal to F1 by A1, or we can say that mathematically related. So that is F1 is the force on the smaller piston, which is area A1. F2 is the force on the larger piston, where area is A2. So we can take as F1 by A1 is equal to F2 by A2. The mathematical advantage you can see, area of a larger piston, area of a smaller piston. So R square by R square. So where R is the radius of the larger piston and small r is the radius of smaller piston. As the radius increases, the value also increases. So here you can see one more hydraulic press, that is the hydraulic press is also known as Burma press, is a device that uses the hydraulic power to multiply the forces, which we have seen like a rough sketch. You can see this is called a hydraulic press. Here it will be a smaller area and here it will be a larger area, and when the piston of this one is applied force, here it increases. So it is based on Pascal's law. This hydraulic press or Burma press, both are same, but they work on the principle of Pascal's law. Now what is the principle of this hydraulic press? Let us see what we were discussing till now. Consider a two cylindrical different cross section areas connected to each other and filled with an incompressible fluid. Means as this is the device which I was drawing from the long time, same. The smaller force F1 applied on the smaller piston, here the force F1 is applied, transmitted to the larger piston of area A2, means it is transmitted from here to here on the piston A2 with a force F2. According to the Pascal's law, as we said that the pressure is constant, F1 by A1 is equal to F2 by A2. Means here what you can see, F2 will become as F1 by A1 into A2, where area is more, this total value multiplied will be larger. So with this we can say, like if I take a simple example, F1 is 2 newtons, area is 4 meters square, then what will be the F2? In case here area is 10 meters square, means this is 4 and this is 10. Now here I am applying the force of 2 newtons. Then if you see here what happens, here the force will become, when you bring this one to here, it will become what? 2 into 10 by 4. So 4, 2 ones, 2 twos means 2 fives are. So it will become 5 newtons. So I am acting only 2 newtons force, but I am showing a result of 5 newtons in this case. So you can observe in this way how the Burma press will help us at a less force, acting a more force on the other end, so that we can lift the vehicles very easily. Where you can see, well, like car mechanics or bike mechanics, they will keep a vehicles on a certain platform and press a machine where they will apply. So let us see the applications. What are the applications? As we said, hydraulic press used in metal forming car and manufacturing and industrial processing. And as already said, hydraulic lifts commonly used in the elevators and vehicle lifts. So next, applying the principle of these hydraulic machines, we get mechanical advantage. As you know, what is the advantage? Load by effect. What is the load? Area of a larger piston by area of a smaller piston. This both. As we said, pi r square by pi r square. Pi gets cancelled. R square by r square. As the radius is larger, the mechanical advantage is also larger. Note, the larger piston is generally referred to as a press plumber and smaller piston is referred as a pump plumber. Press plumber and pump plumber means it is pump and it is pressure. So uses of hydraulic press. It is used for compressing the cotton blades and the straw. It is used for exerting oil from oil seeds. It is used for punching holes in metals. It is used for giving a specific shapes to the metal sheets, and also it is used for servicing the automobiles in the service stations. As already I said in the beginning only, in a two-wheeler and four-wheeler mechanics in the mechanic sheds, they will use this service stations, we call them. So these all are the uses of hydraulic press. So next, coming to the atmospheric pressure. So let us discuss about this atmospheric pressure in the later classes. So thank you for everyone.